Today's notes are all about ratio tables. Now, this is the video. If you don't have the paper version of the notes or you're choosing not to print them, you can take our ratio tables notes right in your notebook. So today, I'm going to ask you to get a regular pencil and also 3 colored pencils. I'm personally using green, blue, and red. If you need to substitute for some other colors, that's fine too. So pause this video and get yourself ready. I'm on page 17 in my notebook, but you may be on a different page as well. So let's title our page Ratio Tables, and then I'm going to give you some instructions for setting up some tables. So I would like a table that has 2 columns and it has 6 rows. So the easiest way that I can recommend to do this is I'm going to use this red line as a guide, and I'm going to make this go down 6 rows on my line. So 1 line, 2, 3, 4, 5, 6. So since that's 6 rows, I'm going to make a nice big table. And I'm going to draw a line down the middle. So that way I now have a table. If you want to go over each of these lines with your pencil, that's fine too. It's really just up to you. So take some time and make sure you have a table with 6 rows and 2 columns. When you're ready, I'm going to keep moving on. So the first column should be labeled cups of water. Cups of water. And the next column is cups of flour. Okay, so if this were a real life problem, it would be about my art teacher. And my art teacher is creating a paper mache mix using 2 cups of water for every 6 cups of flour. So I'm going to jot that down. 2 cups of water and 6 cups of flour makes paper mache. So if I used 4 cups of water, that means I would need 12 cups of flour. The next relationship, I'm going to tell you that there's 6 cups of water, but I'm not telling you yet how many cups of flour. For the 5th line, I'm going to tell you we're going to use 24 cups of flour, but I won't tell you how much water yet. And in the last line, 10 cups of water and a mystery number of cups of flour. We're going to remind ourselves below with a little note. All ratios must be equivalent to, and then we're going to remind ourselves with that original recipe, 2 cups of water, 6 cups of flour. So they're all going to be equivalent to 2 to 6. Or if you're someone who remembers, we can simplify that down to 1, 3. Everything in this table must follow this recipe, even if we're making more or less of my paper mache. So what I'm going to do first is I'm going to talk about some patterns that people see. Now, the first pattern is one that a lot of people see who are younger than 6th grade. So if I were to present this problem to someone who is younger than 6th grade, they might find something that's called an additive relationship. So I'm going to write that. I'm going to use green. So additive. And I'm going to put the words in columns. Okay, it's additive in columns. Now, it's called additive, and I bet you can guess what it means. Additive means you're either adding something or you're doing the opposite, which is subtracting something. And this happens in columns. So we would notice this happening up or down in this particular table. So what I'm going to do is I'm going to show these additive relationships. So a lot of students realize, and I'm going to draw these arrows from the 2 to the 4 and another arrow from the 4 to the 6. And you're noticing a pattern maybe. An arrow from 6 to this blank spot and an arrow from the blank spot to 10. So a lot of students notice that there's an additive relationship because this is getting bigger and it's getting bigger by the same amount. We call that additive. 2 plus 2 equals 4. And 4 plus 2 equals 6. So 6 plus 2 would give me a mystery number. I bet you know it's 8. And then 8 plus 2 would give me 10. That's called an additive relationship because we're adding the same thing every time. It could also happen the other direction where we're subtracting the same thing. Now, let's find the additive relationship over here. So I'm going to draw my arrows again from 6 to 12 to the mystery box to the 24 and to the one below that. Now, it'd be additive, but with a different amount. 6 plus 6 would get me to 12. So 12 plus 6 would get me to my next answer, which would be 18. 18 plus 6 is 24, and 24 plus 6 equals 30. So because those are all in green, it reminds us that we might have additive relationships when I'm looking at the columns on a table. I want you to swap colors now. I'm going to use a blue, for example. So this is a long word. I'm actually going to use this little space up here because it's a little longer. So multiplicative. Okay, so it might be multiplicative in rows. So instead of looking up and down in my columns, we can look at the relationship across each row. And these are multiplicative. That means we're either multiplying or the opposite, which is dividing. 2 is related to 6 using a multiplicative relationship. Times 3 equals 6. So if I read this, 2 times 3 equals 6. Let's check this rule and see if this multiplicative pattern works for the rest. 4 times 3 equals 12. 6 times 3 equals 18. 8 times 3 equals 24. And 10 times 3 equals 30. So this showed in blue that we could have also found the multiplicative pattern in my rows. So depending on which way your brain works, you might see one of these patterns quicker than the other. And as long as your table is in order and your rule or pattern works for the whole table, you can be confident that you have found a way to solve the ratio table. What we're going to do is we're going to go down below in our notebook and we're going to fill out a different table and show how these relationships sometimes get a little mixed up. Now this new table is going to be just like the one above, but it's going to be on its side. So I want only 2 rows. So I'm going to do only 2 rows here. Okay. Now I actually want 5 columns. So what I'm going to do is I'm just going to kind of ballpark or eyeball it. So I'm going to do 1 column here, 2, 3, 4, 5. My last one's a little bigger, but that's okay. I'm also going to draw my line here. We're going to label the top box cups flour. So it's a new recipe here. The box below that is going to be cups sugar. Okay. While most tables are vertical, we can also show tables horizontally. It's basically like a vertical one that just got tipped over or put on its side. We're going to look at this one. I'm going to give you some information. It's a new recipe. We're doing flour and sugar. Maybe we're making cookies. For 3 cups of flour, I'm going to put a 3, we use 8 cups of sugar. Up here, we're going to do 9 cups of flour. Next to that, we're going to do 12 cups of flour, and then we're going to leave the last box blank. Next to the 8, we're going to have a blank, and then under the 12, we'll do 32 cups of sugar, and next to that, we're going to do 16 cups of sugar. Now, the reason I like to go over this table is for 2 reasons. Number 1, it's to remind us that tables can be horizontal or they can go left to right, but it's also to show you some strategies when the values are out of order. So we're going to put a star here. So we're going to write a little statement, and it says, if values are out of order, comma, use multiplicative, M-U-L-T-I-P-L-I-C-A-T-I-V-E. And then we're going to write relationships. What you're going to notice is, although on the top it looks like we could do an additive relationship, 3 goes to 9, goes to 12, goes to something else, if we look below, we notice that not all these values are in order. So if I tried to find an additive relationship here, it would go from 8, a number a little bigger, number bigger, 32, and then we go back down to a smaller number. So clearly they have mixed up the order of the values in this table. So I can't just keep adding something, because I can't add something to 32 and somehow get to a lower number like 16. So I'm going to show you another strategy you can do when things are a little bit mixed up. So we're going to draw some arrows. So if I start at a number like 8 and I'm trying to find a relationship to this box next to it, I'm going to draw an arrow. I'm also going to draw a corresponding arrow from the 3 to the 9. This should remind you of when we're finding equivalent ratios. I have to look at the relationship between 3 and 9, and I notice that we multiplied by 3. So to keep things equivalent and this recipe tasting the same, we're going to do 8 times 3 on the bottom, and we're going to get an answer of 24. Now, this method will work even if we're trying to find something over here out of order. So I'm going to go to another color, for example, green. I want to find this mystery number. Now, I'm going to actually choose to go all the way back to this 3 just because I feel really good about my 3's facts. So I'm going to draw a green arrow from this 3 all the way over to this missing box. Let's go to the corresponding part, which is down here at the 8, and we're going to draw an arrow all the way over to 16. Now I'm going to look at what I know. I know there's an 8 turning into a 16. That's using a times 2 fact. So we'll do the same thing to the top. 3 times 2 on this green arrow makes 6. So even though some things are out of order and you might have to draw some arrows to some longer spots on your table, you can use multiplicative relationships to find some missing values, especially when things are a little bit out of order. So those are our ratio tables notes. I'm going to zoom back out in case you want to pause and make sure that everything looks the way that it should.